Hey all, this is Jeff Boots with Boots Flipped, and today we're going to talk about safety. Safety first, safety last, and safety always. Those words seem kind of redundant. Of course, safety comes first, last, and always. I used to think that too until I spent time talking with others just like you. I found out that safety is rarely a consideration when things have to get done now. When is the last time you really thought about turning off a live circuit to work on it? Most likely you've worked on something live this week and never even gave it a thought. How do I know? I've been there. I started in this trade in 1990 and have been working in it ever since. It is very easy to get complacent when working around live circuits because it's something we do every day. Think about the last time you changed out a bad light switch. Did you go find the circuit breaker in the panel? Turn it off. Lock out the breaker. Go test the circuit to make sure you had the right one, and then change out the switch? My guess is no. Spending time to do all of that would turn a 5-minute job into a 25-minute job. What does it matter anyway? Well, I'm going to show you why it matters in this video and hope that by the end you will think it matters too. Never work anything hot. This seems like it would be an impossible feat in the world of electrical work, but it's not. I've talked with electricians from all experience levels, and I find they just don't understand how electricity really works and how badly they could be hurt if something went wrong. When informed of the hazards, I find that most agree this is the best method of doing work. I'm sure by now you're asking yourself, what could really be so bad? So let's take a look at short circuits and ground faults. A short circuit is when you have conductors that fault or touch phase to phase. In a 120/240 volt service, you have two phase conductors, an A and B. Each conductor will provide 120 volts from its phase to the neutral or ground conductors and 240 volts from phase to phase. When you touch the A phase conductor directly to the B phase conductor, you will get a short circuit. A ground fault will happen when you touch any phase conductor to anything connected to the grounding system. When you have a short circuit or a ground fault, the following things happen. You cause an arc flash. This flash could be bright enough to blind you, cause serious injury, or even death. So let's look at what an arc flash really is. When an arc flash happens, it can generate temperatures that are hotter than the sun. How hot is that? Try 35,000 degrees Fahrenheit. This will melt copper, turning it into a vapor instantly. Because it melts this quickly and generates this much heat, the copper wire that just caused the fault will expand to 67,000 times its original size at an astounding 700 miles per hour. If you had a number 14 wire, the vapor would expand to the size of an exercise ball in 2 milliseconds, or 0.002 of a second. In contrast, a number 4-aught wire would expand to the size of a Porsche 911 in 15 milliseconds, or 0.015 seconds. Let me break it down even further. In the time that it takes you to blink, 200 number 14 wire explosions could happen. If you lined up those explosions end to end, they would cover the length of a football field. Now that's pretty amazing. If you've seen a number 14 wire in a ground fault and never been hurt, I'd say you were pretty lucky. Okay, so a wire blows up and I move out of the way. Crisis averted. Well, there are other things that happen during a short circuit or ground fault situation. Let's look at them. The rapid expansion of copper causes tremendous air pressure quickly, which creates a loud sound and can have enough pressure to either move you out of the way or send shrapnel flying from the box the fault happened in. The reason that this fault can be so disproportional to the amperage rating of the service is because of the high fault current available on the incoming wires of the transformer that serves this panel. If you look on the main breaker of a traditional residential panel, you will find that the main breaker is rated for a fault current of 10,000 to 22,000 amps. This breaker is made to withstand this kind of fault so it doesn't blow up if there was a short circuit at the panel. Well, you might think that if the fault happens after the main breaker, you should be okay because it will trip. Circuit breakers trip pretty fast, but not instantaneously. It may seem instant to you, but remember the times we just talked about a few minutes ago. That number 4-aught is going to blow up in 15 milliseconds to the size of a Porsche. That's 27 times faster than you blink. The breaker will trip, but not before something catastrophic could happen. I know accidents happen. Could a ground fault or short circuit injury be avoided? Yes. How? Don't work on it hot. If what I'm telling you doesn't make you change how you work day to day, let's look at other things besides getting burned that can happen. Getting shocked, which is defined as touching line to line or line to ground. This happens to us all the time when we're working things hot. It just tingles a bit. The unexpected tingle might cause you to jump back, pull your arm back, possibly losing your balance, then falling off your ladder. Falling could cause a sprain, broken bone, or even concussion. And depending on the distance of your fall, maybe even death. Well, maybe you don't fall and get hurt badly, but another hazard of electric shock is burns. Have you ever had a bad sunburn? It hurts and you can't get away from it. Now think about a second or third degree burn from a shock. Not only can you not get away from it, but the pain can be excruciating and debilitating. Still not convinced? Let's look at the cost. The average ER trip cost $1,500 to $3,000. The average lost time for a broken leg, 6 to 8 weeks. The average lost time for a second-degree burn, 2 to 10 weeks. Cost to the company for the loss and company insurance rates also going up. When insurance rates go up, labor prices have to go up. This in turn keeps you from being competitive when bidding jobs. If you can't be competitive when bidding jobs, then you don't get the work. When you don't get the work, you have to lay people off. And who gets laid off first? Right. The workers that have the best chance to get hurt and cost the company more money. Is that you? Remember that the person most responsible for your safety is you. I hope that you took notes so you can participate in the discussion during class. If not, rewind and play again. Remember, this is a video and you can watch it as many times as you need until you get it. I'll see you next class. Be safe.